Well, Algebra 2, in our lesson today, we're going to be continuing simplifying rational expressions. However, today we're going to be using the sum and difference of cubes formulas to help us do that. So I wrote a few reminders here on what sum of cubes and difference of cubes are. I wrote their formulas up here, as well as a list of a few perfect cubes to help kind of bring this back to the front of our memory here. It's been a little while since we dealt with these. So let's go through a couple examples on how to do sum and difference of cubes, and then we'll apply those to some rational expressions. So first example, let's look at 81 plus 375x cubed. So first thing we did was always looked at our numbers here. Were our numbers on our list of perfect cubes? They are not. That means that we have to divide a number out of here. So we go through our list of common factors and we pull out our greatest common factor. I did this off camera and it's 3. So when we pull 3 out of these, 81 divided by 3 is 27. 375 divided by 3 is 125 x cubed. So when we pull that common factor of 3 out, we're left with 27, which is on our list of perfect cubes, 125, which is also on our list of perfect cubes, and of course x cubed is a perfect cube. So now we have to identify what a and b are. A is going to be what we cubed to get to 27, and that's 3. 3 cubed equals 27. We have to identify what our b is. What do we cube to get 125x squared? Well, let's look at our number first. We cube 5 to get to 125, and of course we cube x to get to x cubed. So now we've identified what our a is and what our b is. Now we just plug that into our sum of cubes formula. So it's going to be a plus b, or 3 plus 5x. We're going to multiply that by, in our second set of parentheses, our first term is a squared. That would be 9 minus a times b. 3 times 5x is 15x. And then finally, b squared, that would be 25x squared. So this is our factored form of our original polynomial expression up top here. Let's go through one more example, and then we'll apply this using rational expressions. About 108x cubed minus 500. So neither 108 or 500 are on our list of perfect cubes, so we need to factor out our greatest common factor. Again, I did that off camera, and it was 4. When we factor 4 out of 108, we get 27. 27x cubed. And when I factor 4 out of 500, I get 125. So those numbers should look a little bit familiar from our first example. So we know to identify our a and our b here. What do we cube to get 27x cubed? Well, 3 cubed gives us 27. X cubed gives us x cubed. What do I cube to get 125? That'll be our b, and it's 5. 5 cubed is 125. Now we're going to plug our a and b into our difference of cubes formula here. So a minus b would be 3x minus 5. Our larger set of parentheses here, we're going to start off with a squared. That's 9x squared plus ab, which would be plus 15x, and plus b squared. Well, 5 squared is 25. We can't forget to carry down that common factor we factored out first. So there is our factored version of our original expression up top here. Okay, so now that we've kind of refreshed our memory on applying sum of cubes and difference of cubes, let's use this looking at some rational expressions. First example here will be 6x squared plus x. That's all over 216x cubed plus 1. All right, so up top here, we just have a binomial. We do not have a sum of cubes or a difference of cubes up top there. So what we're going to end up doing with the numerator is factoring out our greatest common factor. That'll be our strategy on our numerator. Let's look at our denominator. Is 216 on the list? Yes, it is. Is x cubed a perfect cube? It is. Is 1 on our list? Yes, it is. So we have a sum of cubes on the bottom. We have a binomial. We're going to have to factor out the greatest common factor on top. So let's go ahead and do that. If we factor out the greatest common factor on top, that's x. So taking x out of x squared plus x, we're going to get 6x plus 1. The marker seems to be going there. Okay, how about, let's look at the bottom here. If we identify our a and our b here, what do we cube to get to 216? We cube 6. And what do we cube to get to x cubed? We cube x. So our a is going to be 6x. What is our b going to be? I don't know. What do we cube to get 1? Just 1. So here is our a and our b, and we're going to plug that into our sum of cubes formula. And that'll be our new denominator. So we're going to get a plus b, which is going to be 6x plus 1. Okay. And then we're going to get our second set of parentheses here, a squared plus ab plus b squared. We're going to have 36x squared. That's a squared. Okay. And then we're going to do minus ab. A times b is just 6x, so minus 6x. And then finally, we're going to add b squared, so we'll be adding 1 at the end here. So this is our factored version of our denominator here, using our sum of cubes formula. But look what we got here. We have a 6x plus 1. We have that factor in the top. We have that same factor in the top. We have bottom and top, so we can cancel them out. So we're going to end up with x over 36x squared minus 6x plus 1. And there is our answer for that example. This is our simplified version of what we were originally given up top here. We'll try one more example here. We're going to look at 27x cubed plus 1 over 9x squared minus 3x plus 1. All right, so let's look up top here. We do have binomial. We have 27 on our perfect cube list. Sure is. It's x cubed a perfect cube. It is. Is 1 on our list? It is. So we have a sum of cubes in our numerator. How about in our denominator? We don't. We have a trinomial with a lead coefficient greater than 1. So we may be using the AC method on that one, but let's take care of our sum of cubes first here. Let's identify what our a and our b will be. So our a is going to equal whatever we cube to get to 27x cubed. Well, what do we cube to get to 27? 3. And what do we cube to get to x cubed? X. What's our b going to be? That's going to be whatever we cube to get to 1. That's just 1. So let's plug our values of 3x and 1 into our sum of cubes formula. And up top we'll end up with 3x plus 1. And what are we going to have here? A squared is going to be 3x squared. That's going to be 9x squared. We're going to subtract a times b, 3x plus 1, so it'll be minus 3x. And finally, we're going to add our b squared, add 1 squared plus 1. And we put that over our denominator of 9x squared minus 3x plus 1. And it's nice when this happens. So we don't have to worry about applying the AC method to the denominator because we have matching factors on top and bottom that we can cancel out. So we could cancel that entire denominator, that second set of parentheses on the top, and we are left with 3x plus 1 is our simplified version of what we were originally given up here. So hopefully going through those first couple examples kind of dusted off what we knew about sum of cubes and difference of cubes. Hopefully these last couple examples you saw how we can apply that to simplifying rational expressions. So should be on your way to work some practice problems now. If you have any questions or if you're stuck, please email me. We'll work through those. Otherwise, go to your homework.